Hello, Professor Haywood here. Welcome to lecture 1.3. We're going to be talking about visualizing numerical data with histograms. So histograms are going to be the main topic of discussion in this section. This is going to be kind of a longer section. There's a lot to say about histograms, and unfortunately it takes a little bit of work to get Excel to make a proper histogram. So we'll go through all of that. Make sure that you have your notes either printed or downloaded so that you can take notes, and then also make sure that you have the data set, the Excel spreadsheet data for 1.3 downloaded so that you're ready to work out examples as we go through this. So without further ado, I'm going to disappear and take you through the lecture. Okay, so let's just start off by making sure that we can read histograms. These are very, very similar to bar charts. Okay, once again, when we're starting with analyzing a data set, we're usually starting with raw data, and then we will organize that data into frequency distributions, relative frequency distributions, and then we'll make some kind of graph out of it. And in this case, we're going to make histograms instead of bar charts. But they're really, really similar. Histograms are like bar graphs, except that the bars don't have any gaps, right? So let's just practice reading these. Here's an example. It says the histogram below shows the number of Atlantic hurricanes over a period of many years. So you can see the frequency along the y-axis and the number of hurricanes along the x-axis. And so we're asked all kinds of questions to make sure that we can read the information from the graph. Part A asks, how many years saw 12 hurricanes? And then 16 hurricanes, right? So for 12 hurricanes, we would come over to the x-axis, to the number 12, right? This bar represents the number of years where there were 12 hurricanes, okay? And so we can follow that over to the y-axis and see that there were 5 years that saw 12 hurricanes, right? So for 12 hurricanes, it was 5 years. Okay, for 16 hurricanes, well, there's no bar for 16. That's because there were no years, there were 0 years that saw 16 hurricanes. So there were 0 years in which 16 hurricanes occurred, right? So this is how we read a histogram. Part B asks, what's the smallest number of hurricanes in a year during this period? So looking at our x-axis, we can see that the number of hurricanes per year ranges from 4 to 19, right? So it looks like the smallest number of hurricanes in any given year was 4. There was 1 year where only 4 hurricanes occurred, right? So we'd say 4 hurricanes. That's the minimum. Part C asks, what number of hurricanes per year occurred most frequently? So again, looking back up at the graph, the number of hurricanes that occurred most frequently would be the bar that has the highest frequency, which would be this bar right here representing 11 hurricanes, right? 11 hurricanes occurred 10 times. So what number of hurricanes per year occurred most frequently? 11, right? 11 hurricanes. And then part D asks, how many years were the hurricanes counted? Okay, so this will require a little bit of work because each of these bars represents the number of years that this number of hurricanes occurred, right? So there was 1 year where 4 hurricanes occurred. There was 1 year where 5 hurricanes occurred. There were 6 years where 6 hurricanes occurred, and 6 years where 7 hurricanes occurred, and so forth. So if we want to know how many years were the hurricanes counted, we would need to total up the number of years represented by each of these bars, right? So that would be 1 plus 1 plus 6 plus 6 plus 9 plus 4 plus 6 plus 10 plus 5 plus 5 plus 3 plus 1 plus 1, right? So we would do all of that work. So we would say it's 1 plus 1 plus 6 plus 6 plus 9 plus 4 plus 6 plus 10 plus 5 plus 5 plus 3 plus 1 plus 1. And so now you can punch all those numbers into your calculator and see what you get. So let's see. Let me pull up my calculator. 1 plus 6 plus 6 plus 9 plus 4 plus 6 plus 10 plus 5 plus 5 plus 3 plus 1 plus 1. Did I get them all? 1 plus 1 plus 6, 6, 9, 4, 6, 10, 5, 5, 3, 1, 1. Yep, so 58, right? Okay, so hopefully that helps you kind of read a histogram. Let's look at another one, because there can be some slight differences from one histogram to another. So looking at this one, it says the histogram below shows the lengths of a sample of several fish from Black Lake. Okay, notice that this time along the x-axis, each one of these bars does not represent just one number, right? It represents a range of numbers. This bar, we've only labeled every other tick mark, but this would be, 25, 30, 35, 40, 45, etc. So this first bar represents all of the fish that measured between 20 and 25 centimeters. It looks like there was only one of those, right? And this bar represents the number of fish that measured between 25 and 30 centimeters, right, and so forth. So, so things can be a little bit different. In this case, the bars have been grouped into what we call classes, and we'll talk about that in a little bit. But let's answer these questions. How many fish were between 30 centimeters and 35 centimeters? That would be represented by this bar right here, right? 30 and 35. And it looks like there were 5 of those fish, right? So 5 fish. Part B asks, what proportion of fish were between 30 and 35 centimeters? So we know the number of fish was 5. The question is, what's the proportion, or what's the percentage of fish that were between 30 and 35 centimeters? So, to get that number, I think we would have to count up the total number of fish in our sample, right? So we know that there was 1 fish here, and 4 fish there, and 5, and 6. So this is the same kind of thing as the example that we just saw on the previous page, right? We would say 1 plus 4 plus 5 plus 6 plus 7, etc., right? So the total, I'm just going to call this the total. The symbol that we use for the total usually is a lowercase n for our sample size, right? So we say, well, it's going to be 1 plus 4 plus 5 plus 6 plus 7 plus 5 plus 5 plus 3 plus 3 plus 1. And then you can punch all of that into your calculator. Let's see if we can do it in our head, right? This is 5 plus 5 more is 10, and then 16, and then 23, 33, 36, 39, 40. So we have 40 fish in total. So the proportion, okay, and the symbol that we use for the sample proportion is p hat. We would say the proportion of fish between 30 and 35 centimeters would be, well, there were 5 fish between 30 and 35 centimeters out of 40 fish in total. And so we can punch that into our calculator and see what we get. 5 divided by 40 is 0.125. Okay, next question. Which length category had the greatest number of fish in it? Well, this bar is the tallest, right? There were 7 fish that belonged to this category, and that bar represents the fish that were between 40 and 45 centimeters. So we'd say 40 to 45 centimeters. And then finally, part D, how long was the largest fish in the sample? Well, the smallest fish in the sample was somewhere between 20 and 25 centimeters. The largest fish would be in this category right here. We can't say for sure what the exact measurement was, but we know that it was somewhere between 65 and 70 centimeters. So we say somewhere between 65 centimeters and 70 centimeters. Okay, so this is how we read histograms. Hopefully that makes some sense to you. Let's talk about this issue that arose when we compared the first example to the second one, right? In the second example, we had the lengths of the fish were grouped into classes, right? So let's talk about classes for numerical distributions. Oftentimes, there are going to be so many values in our raw data that having each value be its own category in our frequency table would just give us a pretty useless summary. So here's an example of that, right? Let's suppose that the birth weights of 15 babies are given in this raw data below. Okay, so here's our raw data for the birth weights. If we were to make each of these individual numbers its own category in our frequency table, we would end up with a frequency table that looks something like this. And as you can see, this isn't a very good summary. It's like all of these, like 2.2 only occurred once, 2.5 only occurred once, right? Some of them maybe occurred a couple times, but it just doesn't give us very good information. And if you look at the graph also doesn't really tell us anything about like, it just doesn't give us good information about where the data is bunched up or anything like that. So, so what we will do in cases like this is we will group our data into classes. So if the variable takes on a lot of different values, we group the data into intervals, which we call classes. So in the baby weight example, instead of making each weight its own category, we can group the weights, right, into increments of, in this case, it looks like we've grouped them into increments of half a kilogram, right? So the first class, the first range goes from 2.0 to 2.4, and then the next one goes from 2.5 to 2.9, and so forth. And then we can count up, right, how many babies were in each of these weight classes, right? And we get a much nicer looking histogram, a much better looking graph out of this, right? It gives us a better sense for kind of what the shape of the distribution is, which is something that we'll talk about a little bit later on. Okay, so as we've already mentioned, the data from example 2 about the length of the fish, those were grouped into classes, while the data in example 1, right, on page 1, that was the number of hurricanes. Those were not grouped into classes because there were only so many there weren't that many different unique values for the number of hurricanes, right? So we could easily leave things not grouped into classes and still get a good looking graph and useful information out of that graph. Okay. Now, a couple things to note about the way that we write out these classes. Sometimes Excel will write out a frequency distribution like this. The problem here is that the upper class limit, we call this the upper class limit, for our first class is the same as the lower class limit for our second class. And that's an issue because then it's ambiguous as to which class we should count a certain individual to be in, right? So like if somebody weighed if a baby weighed exactly 2.5 kilograms, It's like, should we count that baby in class 1 or should we count that baby in class 2, right? Like, it's not clear when we list the classes this way. And so what I prefer, and what is generally preferred in most statistics that I've seen, is instead of ending our first class in the same place where we start our second class, and ending the second class at the same place where we start the third class, instead of doing it that way, we'll end the first class right before where we start the second class, right? So we'll end the first class at 2.4 and then start the second class at 2.5. Or you could write it this way and say, well, the first class is going to go from 2.0 to 2.49, and then the next class will start at 2.5. But it's still clear in this case that where 2.5 belongs, right? It belongs in the second class. Okay. In the case of Excel, the way that Excel counts in the same way that we've described down here. So Excel might write the first class going from 2.0 to 2.5, but if a baby weighed exactly 2.5 kilograms, they would not count that in the first class. They would put it into the second class. So really, Excel is doing something more like this. It's just writing it this way, which is a little bit annoying. The class width is a term that I'm going to use when I'm asking you to create a histogram. I might say use a starting point of 2.0 and a class width of 0.5, right? So the class width, when I'm giving you the class width, I'm just describing what the width of the interval is. Okay. Now, a common misconception for students is that when we calculate the class width, we're going to do this by subtracting the upper class limit minus the lower class limit. In other words, we would do like 2.5 minus 2.0. And that works when you have a frequency distribution that's listed in kind of this ambiguous way where this number matches that number. But if we list it the way that we prefer, okay, so that there's no ambiguity as to where like 2.5 lands, then obviously we wouldn't want to do 2.4 minus 2.0 because that would tell us that the class width was 0.4 when really the class width should be 0.5, right? 0.5. So the way that we calculate the class width is that we subtract consecutive lower class limits. So it wouldn't be calculated as 2.4 minus 2.0. It would be calculated as 2.5 minus 2.0. Okay? It wouldn't be calculated as 2.49 minus 2.0. It would be calculated as 2.5 minus 2.0. So all three of these frequency distributions have the same class width. Okay? And I've already given away the class width is 0.5. Actually, let me show the work, right? It would be, in each case, it would be 2.5 minus 2.0, which is 0.5. Note also that each class should have the same class width. So if I have a class width here of 2.5, then the class width, of 0.5, then the class width here should also be 0.5. We shouldn't be changing up class widths as we make our frequency tables. So let's practice with these concepts a little bit. Okay, we're given a histogram, and we're asked some questions about it. Part A asks for the class width, Part B asks for the sample size, and then in Part C we're going to try to reconstruct the classes based on the histogram that we have here. Now, unfortunately, when I printed this, I printed it black and white, and so you can't see the lines between the bars very well. I think on yours these bars are blue, and so it'll be a little bit more clear where the separations are, but we should be able to still figure this out. So Part A is asking, what's the class width? Well, notice that the way that this histogram was given to us, they're putting the lower class limits for each bar, but they're not putting the upper class limits for each bar. And that's totally fine when it comes to trying to decide what the class width is, because the class width is not upper class limit minus lower class limit. It's lower class limit for the second class minus lower class limit for the first class. So it would just be 4 minus 1, right? The class width would be 4 minus 1, which is 3. And you'll notice that you have the same class width. 7 minus 4 is 3, 10 minus 7 is 3, and so forth. So all of these class widths are the same. They're all 3. Part B asks for the sample size. We've done this kind of problem a couple times now, but we could count up, right? There were 2 individuals in this first class. There were, it looks like 9 individuals in the second class, right? So maybe I'll just write them on top of the bar. 2, 9, 4 individuals here, 6 here, 7 here, 8 here. So the sample size, n, would just be 2 plus 9 plus 4 plus 6 plus 7 plus 8. I know that 4 plus 6 is 10 and 7 plus 8 is 15, so that's 25 already. And then I've got 11 more, so it looks like 36. Okay, so our sample size is 36. So finally part C, where it says reconstruct the frequency table. Well, again, these numbers down here are our lower class limits. So I'm just going to write in my lower class limits: 1, 4, 7, 10, 13, 16, and 19. And then I can come back and I can put in my upper class limits, right? My first class, if the second class starts at 4, then my first class should really end at like 3.9, right? And if the third class starts at 7, then my second class should end at maybe 6.9, right? And I'm going to proceed that way. This will be 9.9, 12.9, 15.9, 18.9, and then, well, if I go up 3 more, that would land me at 22, so this should end at 21.9, okay? And then as far as the frequencies, right, there were 2 individuals in this class, 9 individuals in this class, right, and so forth. 4, 6, 7, 8. Oh, I guess I didn't even need that last class, right? So that's that. So hopefully that makes some sense to you. The next thing that I want to cover is how would we create histograms in Excel. So remember that there are step-by-step instructions on how to do this in the Excel stats procedures handbook on Canvas. Okay, so if you forget how to do this, you can always reference that. Okay, and kind of teach yourself how to do it. There will be a video there with instructions as well. But let's go through the next couple examples in Excel. So we want to, it says the following data represent the number of available cars in a sample of 50 households, right? So it looks like some researcher went out and they knocked on a door and they said, hey, how many cars do you have? And the first household said, we have 3 cars, right? And then they went to another household, they said, knocked on the door, said, hey, how many cars do you own? And they said, we own 0 cars, right? So this is what this data represents. And we're being asked to use Excel to recreate this frequency distribution and this histogram, okay? So let's see if we can do that. Let's see if we can use Excel to create these charts. So if you have the data for 1.3 spreadsheet opened up, then you can follow along with this example. And we're going to start off pretty much the same way that we made bar charts, okay? It looks like from the frequency table and the histogram that we saw in the notes that we don't want to group this into classes or anything. So I'm just going to start off by selecting the data. You can select all of the data by holding down Shift, Control, and then the down arrow. Okay, that'll select all of the data in that column. And now we want to insert a pivot table. So I'm going to go to Insert, Pivot Table. Now we need to tell Excel where we want that pivot table to be stored. I want to store it not in a new worksheet, but in the existing worksheet. And I'll just put it right here. So now what we can do is take this available cars variable, click it and drag it down to rows, and you see now that it's already making our classes for us. Actually, these are not grouped into classes, but it's already listing out the possible answers that were given. And then to get the counts, to get the frequencies, we can take this variable, again, click it and drag it over to the values box. And then you'll notice that Excel does something kind of strange here. Instead of counting up the number of responses in each category, it's finding the total, it's finding the sum of the responses in each category. So it's basically taking the total and then multiplying it by this number, which is not what we want. We just want it to count the values. So what we'll do is click this little down arrow next to the sum of available cars. We'll go to Value Field Settings. Then we'll go to Show Values As. Sorry, not Show Values As. We want to stay in the Summarize Values By tab and click on Count instead of Sum. Right? We want to show the values as a count. Okay, so now we can see really clearly that, okay, there were 4 households that had 0 cars, there were 13 households that had 1 car, and so forth. If I want, I can change this column title. Instead of saying count of available cars, I can call it number of households. That seems a little bit more clear to me. And instead of calling this row labels, maybe I can call it number of cars. And I can make this a little wider so that I can see the title. So, so there were 4 households with 0 cars, right? There were 22 households with 2 cars, and so forth. So that's the frequency table. Now, if I want to make a histogram out of this, then I would just select this, go to Insert, and then I'm going to insert a bar chart. There is a histogram button here, but it doesn't work very well. So just use the bar chart, okay? And the only thing is we don't want there to be these large gaps between the bars. I'm going to get rid of this total. I'm just going to select it and hit delete on my keyboard to get rid of that. But these bars, I want them to be wide. I don't want there to be any gaps between the bars. So I'm going to select a bar. I'm just going to click on actually I want all of the bars selected, so I'm going to click on the bars one time. That'll select all of the bars. And then I'm going to right click and say Format Data Series. And so now over here where it says gap width, up here you can change to different settings that you can manipulate, but we want it to be on this chart thing that we want to manipulate, and I want to change the gap width so that there's no gap between the bars. Actually, if I put it at 0, I get kind of an ugly graph, right? So maybe I want the gap to be a little bit bigger than that. I can put it at 5% or something. And now that looks like a pretty nice histogram, okay? We can change the title of the graph to cars per household or something like that. Right, you can do all the same things that we did with bar graphs in the previous section. So you can add axis titles if you want. So we can call this number of cars. We can call this the frequency or number of households or something like that. We can also hide these buttons. And there you go, right? There's a nice looking histogram for number of cars per household. Okay, so looking at the next one, for example 5, says the data below represent the distance in miles that students live from COS. We're asked to draw a frequency histogram for the data, and this time we're instructed to create classes. It says start your first class at 0 and use a class width of 0.5. So what we want to end up with classes like this, okay, and classes on our histogram. So let's head over to Excel and see if we can get this to come out. So we want to go over to the distance from COS example. Okay, so I'm going to start off the same way, right? I'll select all of the data, insert a pivot table, I'm going to insert it into the existing worksheet right there. I'm going to drag the variable to both rows and columns. And I don't want it to sum up the distance, I want it to count the distance. Okay, just like in the previous case. But now notice that over here it's not grouping this into classes the way that I want it to. So to get it to group into classes, what I'll do is select one of the rows and then right click it, and then I'll go down to this group. Okay, so I want it to group into classes, so I'll select group. And now you have an option for what you want the starting point to be, and we want the starting point to be 0. And then it says by, where it says by, that's where you should put the class width, right? So we want a class width of 0.5. Okay, and now you notice that we get that nice frequency distribution that we saw in the notes. You'll notice that Excel is doing that thing that I kind of warned you about, where it's starting the first class, or stopping the first class at the same place where it's starting the second class, which is a little bit annoying, but that's fine. We'll accept that as is. Okay. If I want to insert a histogram now, well, I'll just select this pivot table that I created and insert a bar chart. Okay, and then I can get rid of that guy, make the bars wider by making the gap go down to maybe 5 or something. And there we go. Now we have a nice histogram there. Again, I can change the title of the graph, I can add axis titles, I can add data labels if I want, right? We can do all kinds of things to manipulate this. But that's all I'm going to do for now here on that graph. Okay, so going back to the notes, there is a tricky thing here that we need to be aware of, and it's that sometimes there will be classes that have no observations attached to them, and we'll call these things empty classes. So to give you an example of what I'm talking about, if we look back at example 1, the classes 15, 16, and 17 are empty, okay, because there were no observations here for 15, 16, and 17. The issue that Excel has with this is that if there's an empty class, Excel won't even put it on the graph, which is bad. We want the empty class to show up on our graph, and so we have to do a little bit of work to get Excel to do this, to get Excel to display the empty classes. Okay. Now, the way that we get Excel to display the empty classes depends a little bit on whether we have grouped data, like in example 5, or not, like in example 4. In any case, there are once again step-by-step instructions for this in the Excel Stat Procedures Handbook. So let me walk you through a couple, and if you forget how to do it in the future, that's okay. We will, you can look it up in the Excel Stat Procedures Handbook, okay? Okay, so here we have more lengths of fish, I guess. This time they're 40 fish from Lake Kauai. Okay, and we want to construct a histogram starting our first class at 12 and with a class width of 8. And kind of as a spoiler, there's an empty class in this data set, okay, and we'll want to make sure that we display that empty class, okay. So let's see if we can get Excel to do this. Let's head over to Excel. So moving over to the length of fish example. Again, I'm going to start off by Control-Shift down, so I select all of my data. Then I'm going to insert a pivot table. I'm going to insert it in the existing worksheet right there. And make a frequency distribution for the length of fish. I don't want it to sum up the length of the fish. I want it to count how many fish were a particular length. And now I want to group these into classes. Starting at 12, yeah, we were asked to start at 12 and to use a class width of 8. So I'm going to change this to 8. Say OK. And yeah, you'll notice that the class from 68 to 75 is missing, right? We have a missing class, and we want to make sure that Excel displays that missing class. Okay, so to get it to show the missing class, what we'll do is we'll select one of the rows, right? Then we'll right-click it, and we'll come to Field Settings. So we'll click on Field Settings, and then under Layout and Print, we'll click the box that says Show Items with No Data. So you click that box and say OK. And now that missing class shows up. We also get a couple other classes, greater than 84, less than 12. If I want to hide those, then I'll click this little down arrow and I'll just deselect the less than 12 row and the greater than 84 row. And now I've got a nice looking frequency distribution. Now when you did this, it's possible that it didn't put a 0 here. It maybe just left this count blank next to the 68 to 75. So to get it to show a 0, you select the row, right click, and then go to Pivot Table Options. And under this Layout and Format, you'll click the box that says For Empty Cells Show, and then type in a 0 there so that it shows the 0 in your chart. Okay. Now from there, we can insert a bar chart to get a histogram. So we'll insert a bar chart, and you'll notice that it displays the empty class in the bar chart. We can get rid of this total. We can make the bars wider so that it looks like a histogram, as it should. Okay, and now we've got once again, a nice looking histogram. You can change the title, add axis titles, all of that good stuff. Okay. Okay, so that does it for that one. Let's look at another one. So this one says 16 randomly selected COS students were asked how many romantic partners they had had up to that point in their lives. So some of the students hadn't had any like boyfriend or girlfriend or anything like that, and some of them had been quite prolific with their dating. Okay, we're asked to construct a histogram for the data and not group into classes, okay? But notice that we are going to have some empty classes. Nobody answered 2, right? Nobody answered 6 or 7. And we want to make sure that Excel will display those empty classes. So let's head over to Excel and see if we can get it to produce a chart and a graph that looks something like this. So back in Excel, we'll go over to the Romantic Partners tab. And again, I'm going to select my data. I'm going to insert a pivot table here in the existing worksheet. I'm going to drag the variable over to rows as well as to values. I don't want it to count up or to sum up the number of values. I want it to count them. So I'm going to click the arrow, go to Value Field Settings, and say count up the values, don't add them up. Okay, so far so good, but we have all these missing classes, right? It's not displaying the 2, it's not displaying the 6 and the 7, and so this is a little bit of an issue. Now, unfortunately, we can't use the same technique that we did before because we haven't grouped these into classes. And so if I select a row and I go to Field Settings and I go to Layout and Print and I say Show Items with No Data, it doesn't make any difference. It's still not going to show them. Now I could group these into classes. I could say Group into Classes and just do a class starting at 0 and have a class width of 1. The problem with this is that for some reason Excel always groups that last class it groups the last two values in that class together into one class. And for the life of me, I cannot figure out how to get Excel to not do this. So this isn't going to be appropriate either. So I'm going to say ungroup so that it goes back to the way it was before. Unfortunately, the best way that I've been able to find to get Excel to display the empty classes is to just do it manually. And so what I mean by that is I'm going to take this, I'm going to copy it, and then I'll paste it. But I don't want to do this paste, I want to do just the values, right? So I'm going to paste just the values only. So I'll use that paste option. Let me make these a little bit wider. Actually, I might need to paste this a little bit further down. Cut it and paste it down here. Because I'm going to add some rows, and when I add rows, sometimes that messes up the pivot table. So I don't want it to be at the same level as the pivot table. But I need to insert a row here between 1 and 3, right? So I'm gonna I need to select the entire row, and then I'll right click it and say insert, and I want to shift the cells down, so I'll say OK. Now that opens up a blank space for me to type in 2 manually, and then there were zero students who said that they had 2 romantic partners, right? And then I'm going to repeat that process for 6 and 7. So I'll insert, shift cells down, insert, shift cells down. Now I can type in 6 and 7 and 0 and 0. And if I want it to look like a table, then I can select this and say format as table, and you can select any kind of table that you like the look of, right? And there you go. So it's not so it's kind of a brute force way to do it, but unfortunately, like I said, that's the only way I've been able to figure out how to do it. Okay, so I'm gonna to insert a histogram, I'm gonna select the entire table, then I'm gonna go to insert bar chart. Okay, now the only problem here is that it's displaying this grand total bar. So what I'm gonna do is I'm gonna hit this little button. This is the filter button, and I'm gonna say, hey, don't show the grand total here, and I'm gonna hit apply. So then the grand total goes away, and now I can make these wider by taking the gap down to like 5%. Okay, and now I've got my graph that's displaying all the missing classes. Okay, so it's a little bit of a headache in Excel to display the missing classes, unfortunately, but that's how we would do it. The good news is that I don't think you'll encounter this situation very much. Hopefully you don't have very many missing classes in your histograms, but that's how you would handle that scenario. Okay, so again, you kind of have to follow a different procedure based on whether you grouped into classes or not. Okay. All right. One last thing to mention in this section really quick is when we're dealing with histograms, we can talk about the shape of the distribution. We can talk about the shape of the histogram. This is unlike bar charts, because with bar charts, you can put the bars in any order you like, right? But with histograms, the bars have to be in a certain order because the x-axis has to be in numerical order, increasing order from smallest to largest. Consequently, the bars can't be rearranged, okay? Which means that they're going to have a shape that is inherent, right, to the graph and to the distribution. So there are different kinds of shapes that we could talk about. There are actually lots of different kinds of shapes that we could talk about. We're just going to highlight 4 of them. So this kind of shape would be called a uniform distribution because all of the bars are at the same height. And even if the bars were at slightly different heights, like if you had this kind of situation, we would still consider this like a uniform distribution even though some of the bars are not perfectly at the exact same height, but if they're roughly at the same height, then we call that a uniform distribution. Another type of distribution is called a bell-shaped distribution because it makes a shape that looks kind of like a bell. Both uniform and bell-shaped distributions are called symmetric distributions because if you folded the graph in half, the two halves would match up. Okay, so if you folded the graph in half, like along that axis, the two halves would match up. Where here they would match up when you fold it in half. That's different from the two distributions below it. This one is called a skewed right distribution, and this one is called a skewed left distribution. These are not symmetric distributions. If you folded the graph in half, the two halves would not match up. So these are not symmetric. We call this one skewed right because it looks like you took a bell-shaped distribution and then pulled on the right-hand side. Okay, so we call it skewed right. It's a little counterintuitive because most of the data is on the left. But again, we call it skewed right because it looks like you skewed it to the right. Right? So you tugged on a bell-shaped distribution, but you tugged on the right-hand side and got a skewed right distribution. And for a similar reason, we would call this distribution a skewed left distribution. So one little thing to mention as far as the shape of the distribution is concerned is that the shape of a histogram is going to depend on how you constructed your classes, right? Too many classes are going to result in a histogram that's too sparse to give very good information, like this example. Too few classes will result in a histogram that's too bunched up to give us very useful information. Okay, so sometimes you have to play around with your class widths a little bit in order to see, in order to get a good picture. Okay, and that's more of an art than a science, and it sometimes takes a little bit of trial and error, which is why we're glad we have Excel, which can just make these graphs for us in the blink of an eye. This, I would say, would be a histogram that kind of groups into classes that's just right. Okay, we have class widths that are just right to give us a nice looking graph. Okay. Another thing that will affect the shape of the distribution is where you start your first class. So the class width affects the shape of your distribution a little bit, or at least it affects the look of your histogram. But so does the starting point, right? If you start at 12, you get a slightly different distribution, or a slightly different looking histogram than you get when you start at 10. Okay? But the differences are fairly minor. Okay? So what I would say is there really aren't any set in stone rules for how to set up your classes to get a good histogram, right? It's more of an art than a science, like I said. Given a particular data set, pretty much any choice of classes is likely to yield a histogram with a similar shape. Okay, like here, here I would say that this is roughly a bell-shaped distribution. Whether you started at 12 or 10, you're getting roughly a bell-shaped distribution. And here, almost regardless of your class width, you are seeing, once again, kind of a bell-shaped distribution in each case, right? And it's not a perfectly bell-shaped distribution, but it's you know, close enough. Okay. So just to wrap up this section, we'll look at one more set of examples. This one says, consider each data set below. In each case, decide whether a bar graph or histogram would be more appropriate for the data. Decide whether to group into classes, and if so, where to start the first class and what the class width should be. Then open up the data for 1.3 spreadsheet and create the graph. Comment on the shape of the distribution. So we'll run through these kind of quickly. Looking at this first one, I would say we're going to create a histogram because the data is numerical. Okay, so it's a histogram for sure. The next question is, should we group this into classes since we're going to be creating a histogram? And in this case, I would say no. It doesn't seem like that would be necessary, really, in this case. Because we don't have a lot of different values. The smallest value I see is a 0, and the largest value I see is a 5. So there are only going to be 6 categories anyway, so there's no need to group that into classes. So we'll say no classes. So then we can head over to Excel and make that graph. Okay, so let's do that. This is example 7, part A, or example 8 rather, part A. So I'm going to select this data, Control Shift down arrow. I'm going to insert a pivot table. I'll insert it here into the existing worksheet. Okay. We weren't told what this data represents, by the way. And I'm not narrating what I'm doing because we've done it 1,000 times. Okay, there's our frequency distribution. Now I can use that to insert a bar chart. Okay, and there's our histogram. As far as the shape of the distribution is concerned in this case, I would call this skewed right. It seems like a skewed right distribution to me. Okay, so let's write that down. So let's say this is, say this appears to be skewed right. Okay, part B. Again, we have numerical data. So I would say we're going to make a histogram. This time there seem to be a lot of different values. If I make each of these values its own unique class, I'm going to end up with a ton of categories. And so I'm definitely going to want to group into classes this time. So let's say group into classes. As far as what my starting point and class width should be, I would say, looking through this, 25, is there anything smaller? 22? I think 22 is the smallest value. And it looks like maybe 59 is the largest one. So I would say if I group this, if I start my classes at 20 and use a class width of 5, then I'd probably get a good number of classes, but we can play around with that a little bit. So I'm going to group into classes. My first kind of guess is to start at 20 and use a width of 5. And if that doesn't produce a nice looking histogram, then I'll just play around with it a little bit and do something different. So let's head over to Excel and play around with this a little. I'm going to go ahead and delete these from example 8A. Okay, I just highlighted them and hit delete. I want to work on 8B now, so I'll select this, Control Shift down arrow, insert a pivot table. I'm going to put it right here in the existing worksheet. I don't want it to sum the values, I want it to count the values. And this time I want to group into classes, so I'm going to highlight and say group. And I said a second ago that I wanted to start at 20 and group by 5s and just see. And yeah, that seems to be a good number of classes, you know. If I had like 20 classes, I might want to trim this down and group by 10 instead of grouping by 5 or something. But this seems to be pretty good. So I'll highlight this, insert a bar chart, and there we go. I would call that bell-shaped. Now if you weren't satisfied with that graph, you could come up here, highlight one of the rows, right-click it, and go to group again. And you could start at 20 and maybe group by 10 instead of by 5. And notice it changes the pivot table but also the histogram at the same time, which is nice. This is also a nice looking graph. I like this graph as well. And I would say it's also bell-shaped, right? So pretty much bell-shaped. So let's write that down. So I would say this is a bell-shaped distribution. Okay. Last but not least, we have part C. And here we have a categorical data set. This is not numerical. And consequently, I should be making a bar graph, not a histogram. But the way that I do that is pretty much the same as the way that I make a histogram. So let's just remind ourselves. We'll go back over to Excel. I'm going to delete these again so that I can work with example 8C. I'm going to select all of the data here. I'm going to insert a pivot table right into the existing worksheet. Okay, drag this into the rows and the values. This time notice that because this is a categorical data set, its default is to count them and not to sum them up, so you don't have to change this when you're making this, because it's already counting those values, which is good. That's what we want it to do. Now I would just select this and insert a bar chart, and that's perfectly fine the way it is. I mean, you might want to change the title, add some axis labels or whatever, but that's how we would make that bar chart, and that looks good as is. We cannot comment on the shape of the distribution. It doesn't make sense, because we could rearrange these values, right? We could make the bars go in any order we want, and consequently we can get it to be any shape that we want. So it doesn't make sense to comment on the shape of the distribution. So we'll just say, well, it's a bar graph, so it doesn't make sense to comment on shape. And that's that. Okay, so that will do it for section 1.3.